How are you, my friends? This is Basic Math Terms, Part 34, the derivatives of transcendental functions. Just to remind you, please, that Part 30 was the start of Calculus 1 terms, and also the algebra terms, you can find them in Parts 1 to 18. Pre-calculus terms, you can find them in Parts 19 to 27. And statistics terms, you can find them in Parts 28 and 29. Now, in this video, we have 8 terms that we need to highlight: chain rule for trigonometric derivatives, chain rule for exponential derivatives, chain rule for logarithmic derivative and logarithmic differentiation, implicit differentiation, Newton's method, successive, and approximation. Now, let's recall that the chain rule in general will be the derivative of f of u, which is f prime of u, times du over dx, where u is a function of x. So we can see now the derivative of sine of u will be cosine of u times du over dx. The same for the derivative of cosine of u will be minus sine of u times du over dx. And the same for the other trigonometric functions. Let's take one example. F of x is equal sine of square root of x plus the square root of sine 7 pi x. Let's find the derivative using the chain rule and the general power rule. F prime will be the derivative of this sine square root of x will be cosine square root of x times the derivative of the inside, which is the derivative of square root of x. This one all to the power half, so it will be half sine 7 pi x to the power half minus 1, which is minus half, times the derivative of the inside, which is sine 7 pi x all prime. So this will be cosine of square root of x, the derivative of square root of x, 1 over 2 square root of x, as you know that. This is the same here, half sine 7 pi x to the power minus half. The derivative of this sine 7 pi x will be cosine 7 pi x times the derivative of the inside again, 7 pi x all prime, which is 7 pi, the coefficient of the x. So f prime will be cosine of square root of x divided by 2 square root of x plus 7 pi cosine 7 pi x divided by 2 sine square root of 7 pi x. Now, these are the terms for the exponential function and the derivative. If we have a function f of x is equal a to the power x, f prime will be ln of a times a to the power x. Now, this is a special case exponential function, base e, it will be f prime will be e to the power x. And here times ln of e we know it's 1. Now, the chain rule version will be the derivative of a to the power u, ln of a times a to the power u times the derivative of u, du over dx or u prime. Same for the derivative of e to the power u will be e to the power u times du over dx. Always remember that u is a function of x. Now let's see one example on exponential function. Suppose we have this function e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x, and we need to find the derivative y prime. Here we have to remember the quotient rule, which is the derivative of u over v. And the formula is u prime v minus v prime u all divided by v squared. Remember, the numerator is all this, e to the power x minus e to the power minus x, and the denominator here, e to the power x plus e to the power minus x all squared. You can go slowly here and check the answer. Find the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over all this squared. So the final answer should be 4. Please try to multiply these and check your answer. It will be 4 divided by e to the power x plus e to the power minus x all squared. That is dy over dx. Now this is logarithmic functions, if we have a function log base a of x, we need f prime of x. 1 over ln of a is the base here, times 1 over x. And if we have ln of x, the derivative will be 1 over x only, because when you multiply times 1 over ln of e, which is 1, so it will be 1 over x. Chain rule will be the derivative of log of base a of u, 1 over ln of a times 1 over u times du over dx. Now the important formula is number 4 here that we use a lot. The derivative of ln of u, simple formula will be directly u prime over u. Now let's see an example on logarithmic derivatives. We have to find the derivative of y equals ln of square root of x plus 1. We can see from the question that square root of x plus 1 here is du, because we have here ln of u. So let's find only first the derivative of u prime. So if u is equal to square root of x plus 1, the derivative will be the derivative of the inside, which is x plus 1 prime, divided by 2 times the same square root of x plus 1. So it will be 1 over 2 square root of x plus 1. Leave it now, we will use it here. Let's go back. Y equals ln of square root of x plus 1. Directly we say y prime will be u prime over u. U prime we have found 1 over 2 square root of x plus 1 divided by u, which is square root of x plus 1. So this is the division of two fractions. The first one times the reciprocal of the second. So y prime will be 1 over 2x plus 1. Now this is logarithmic differentiation. And this is an important method we can use when we have functions involving complicated products, quotient, or powers. You can see that in Calculus 1, lecture number 12. So you can say, given y equals f of x, take ln of both sides. So it will be ln of y is equal ln of f of x. Simplify using the laws of logarithms. Then we differentiate with respect to x on both sides. We multiply both sides by y equals f of x, then you will get y prime. Please check lecture number 12 for more examples. Explicit and implicit. This is the lecture number 13 in Calculus 1. Functions expressed explicitly like this one. We can write easily y equals f of x is equal something in terms of x only, like x cubed sine of x, y equals f of x like this polynomial function, or y equals f of x like x plus ln of x. Now the equations expressed implicitly like these, x squared plus y squared is equal to 1, y cubed is equal to 4 minus cosine of xy, and this one is more and more complicated. So when you cannot write y equals something in terms of x, then you can use implicit differentiation. Let's see an example on implicit differentiation. Let's take the equation y equals x squared times sine of y. Not easy. Let's take the derivative of both sides. D over dx of this y times d over dx of this product here, x squared times sine of y. So remember, product rule, u prime v plus v prime u. So this will be y prime, the derivative of x squared times sine of y plus sine of y prime times x squared. Simplify that, it will be 2x sine of y plus cosine of y, y prime. See this one here, sine of y prime. Y is a function of x. So it will be cosine of y times y prime times x squared. So y prime minus cosine of y, y prime x squared. Bring this on the other side is equal to 2x sine of y, because we need to take a common factor here, y prime. Y prime is the same as dy over dx. Let's take it as a common factor. So it will be 1 minus cosine of y times x squared in the bracket times dy over dx equals 2x sine of y. So when you divide by this coefficient of dy over dx, you get y prime which is dy over dx, 2x sine of y divided by 1 minus x squared cosine of y. This is the derivative using implicit differentiation. Newton's method. This is lecture number 14 in Calculus 1. We can use this method to find the zeros of a function written in this form, y equals f of x, by a sequence of successive approximations. So we can use this equation here for Newton's method. X sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime. See, there's a derivative here of x sub n for n equals 0, 1, 2, 3, 4, etc. X sub 0 here, we call it initial guess. Let's see one example here, and you can see the others in lecture number 14. Suppose we need to approximate fifth root of 30 without using any calculators. And let's take the initial guess, x sub 0 is equal to 2. So I start here by letting x equal this number that I need to approximate. Raise both sides to power 5. So x power 5 will be equal to 30. And take 30 on the other side. Let's construct a function. F of x is equal to x power 5 minus 30. Find f prime. 5x to the power 4. Let's use Newton's method. This is Newton's method with x sub 0 is equal to 2. So the first approximation will be x sub 1 will be x sub 0, which is 2, minus, replace 2 in the function, and then replace 2, which is the initial guess, in the derivative down. Simplify the numbers, 2 minus 1 over 40. Please try to do it. This is 32 minus 30. That's 2. Divided by this, you can cancel one of the 2's. It will be 79 over 40. This is the first approximation. You can find the second, the third, etc. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.